step number 1, there's 5 in total here. So the first thing that we're going to do is we're going to simplify, if we can, and then find the domain. So simplify that rational function if we can do it, like factoring, canceling, and then find the domain. That's step 1. Okay. Step 2, we're going to get the x-intercept. Get the x-intercept. So simplify, find the domain. And we're going to talk about how to do each of these things, but I want to lay out the map for you as we go. Okay? Just a little bit. Step 1, simplify, find the domain. Step 2, get the x-intercept. Step 3, get the y-intercept. Hey, Lauren, come on in. Bless you. Step 4, we're going to get the asymptotes. Step 5, last and least, we're going to sketch. All right, let's now go back and talk about how we get all of these things, because you actually already know how to do all this stuff. You just never put it together in this sort of process, okay? So when I'm talking about simplifying or find the domain, if we're given a rational function, say f of x equals p of x over q of x, all right, if this is our generic rational function up here, how do we find the domain? What's the way to do it? Yes, what do you got? You got it. Exactly. We're going to set q of x equal to 0, and we're going to solve. That's exactly how we're going to do that part. So the highlighted part is how we accomplish the step. All right. High CPU storage. Very good. All right. Intercepts. Well, we've been finding x-intercepts for a long time. How do you, in general, find the x-intercept for a graph? You got it. Set y equal to 0. Set y equal to 0 and solve. But in this case, we don't have y's, do we? What do we have? Yeah, we have f of x. So if f of x is equal to a 0, okay, imagine this. If this is 0, so 0 equals something over something else, right? If I cross multiply, what do I get? If I cross multiply both sides by q of x, what do I get? Yeah. P of x equals what? So that's the same thing as this, isn't it? Ooh, mind blown. Look at that. Okay, so therefore we could also say this. Say, or just set p of x equal to 0 and solve. Either way, you obtain the same thing. So either one of those two options, however your brain sees it, will work out just fine for you. Okay, get the y-intercept. How do you get the y-intercept for any graph that we've ever done before in our lives? Yeah, you got it, right? So we're going to evaluate f of 0, or set x equal to 0. That's exactly what that means. And see, so look at that. You guys already pretty much know the first 3 steps. And the last step is just making a sketch. So the fourth thing is the one that we really got to pay attention to. So get the asymptotes. Okay, there are 3 types. Name 2 that you know already. Yeah. There's the vertical asymptote. Yep. And then there's the horizontal, right? Yes. And then there's this third one called the oblique, which I have not yet taught you how to find, which we're going to do today. Okay? Now, here's the thing. You're always going to have vertical asymptotes if your domain is anything other than real numbers. So that one's a given, right? That one matches with step number 1, find the domain. For these two, for horizontal or oblique, you get one or the other. You get one or the other. You never get both together. Okay, so if there's a horizontal, you can cross off oblique. If there's an oblique, you can cross off horizontal. You get one or the other. Make sense so far? Feeling good? Okay, and then to sketch, right? To sketch, we are going to take test points and use our graph 3x plus 2. All right, so I have this rational function, f of x equals x over 3x plus 2. Which part represents the p of x? Yeah, very good. Which part represents the q of x? Very good. So this first one will go kind of slow, and you'll see how fast these pick up as we move along here. So let's go through our steps here. What's the first thing we got to do? Yeah, so can this be simplified any more? No, we're good to go. So let's find the domain. So to get my domain, I'm going to go 3x plus 2 equals 0. So therefore, x has to be what? Nice job, Bobby. So therefore, my domain is all real numbers x such that x does not equal negative 2/3. Feeling comfortable with that? All right. Step 2. What we got to do? Yeah, very good. Get the x-intercepts. So to get the x-intercepts, we found out that we can just set q of x equal to 0 and then, p of x equal to 0 and then solve, right? Well, p of x is x, so just set that equal to 0 and then solve. Oh, hey, look at that. There's our x-intercept. That was easy. Nice. Okay. 3, what's the third step? Get the y-intercept. So what do we do there? Yeah, so we're going to evaluate when x is equal to 0. So in this case, we're going to have this. We're going to have 0 divided by 3 times 0 plus 2. That equals 0 divided by, who cares, because the answer is what? 0. Very good. I love that one too. Awesome. Look at that. We just blasted through those 3 steps, right? So we have a domain, we have the x-intercepts, we have the y-intercepts. Okay, let's talk about the asymptotes now. All right, step number 4. Well, let's talk about the vertical ones. Yes, x is going to be negative 2/3. Very good. That's one of them, right? Okay, now, I'm either going to have horizontal or oblique. How do I determine which of those two I'm going to have? Carefully. Yes, very carefully. Yes, what do you got?
If the top one is equal, or if the top part is equal to more, like is greater than the bottom.
When you say the top part, which part are you referring to?
P of x is greater than.
Which part of P of x? There's a word for it. There's the D. The degree, yes, very good. So what is the degree of the numerator? 1, very good. What's the degree of the denominator? 1. If they are equal, what does that mean? Horizontal asymptote, yes. So I'm going to have a horizontal asymptote. Very good. Okay, and it's going to be the equation y equals what? No. 1/3. Who says 1/3? Okay, how do you get 1/3? Claire, how do you get 1/3, please? I love it. She said it's the leading coefficient of the top divided by the leading coefficient of the bottom. The leading coefficient of the top is a 1. So I have the ratio of 1 to 3. So my degrees are equal. Therefore, I'm going to have y equals 1/3 be the horizontal asymptote. Okay? Will I have an oblique? No. Why not? Yeah, you only get one or the other, right? That's it. That's all you get. Okay, step 5, we have to put all this information into a graph. So you need an inspirational straight edge, and you need to draw yourself a coordinate plane. All right, good. So let's do all that, right? So where are the x-intercepts? 0. Yeah, very good. So I'm going to put, there's an x-intercept right there. What else is important about this graph that we should put on here? Oh, the y-intercept is also 0. So I've come, okay, got that one. What else is important? Asymptotes. Is there a vertical asymptote? Where is it? 2/3. Negative 2/3. Okay, if that's -1, that's -2, -3, -4, -5. Where is negative 2/3? Almost to -1, right? But more than halfway or less than halfway? More than halfway. Good. So you need a vertical dashed line. Remember, asymptotes are always represented by dashed lines, and this is the label x equals -2/3. And that comes straight off of step number 1, I suppose. Oh, no, number 4. There it is. All right, what else is important to put on this graph? Horizontal asymptotes. Where would those be? And it's y equals 1/3. Okay, so if this is 1 on the y-axis, here's 2, here's 3, here's 4, here's 5. Okay, where is 1/3? Less than halfway, yeah. So you want a horizontal dashed line right here. And we're going to label this with y equals 1/3. All right, how are we doing so far? Pretty good? All right. So now, check this out. All right. Our function, because I have these asymptotes, it's either doing this. I'm going to highlight it because I'm taking the guess right now. It's either doing that, or it's doing this, right? Or it's doing this, or it's doing that. That's the only thing it could be doing, right? Because that's the nature of our asymptotes. Remember, as the graph gets close to our vertical asymptote, it becomes like it. As it goes farther away, it becomes like it. I'm wondering if you could eliminate some of those possibilities that I've given to you based on thinking about it and what you can see. What do you think? Yeah, Bob, let's go with you.
Well, you can eliminate all of them except the bottom right one because the bottom right one's the only one that goes through the intercept.
Okay, so he says that you definitely think that this is going on because it goes through the intercept right there?
Yeah.
Okay, good. Would you guys agree with that statement?
Because it doesn't have to. It has to. Yeah, it does have to go through.
I mean, that's an intercept, right? That's an x and a y intercept. So if that's the intercept, then it's got to go through it, right? Okay, I agree with that statement, right? So I don't believe that then it can't be doing this at the same time. Okay, so I would agree with that statement. What about the other two? What are the other two?
Oh, actually, it could be the top left one because that doesn't intercept at all.
Oh my God, you're on top of it. Yes. Why can it not be the bottom left one? What do you think? Yeah.
That would have an x-intercept.
Very good. I love it. That would have to have an x-intercept, wouldn't it? And does it? No, it does not. So it can't be this one either. So it looks like a good sketch for us would be this graph right here. I love how you thought about that. Have we touched a calculator yet? No, we have not, right? But we're gonna in just a second. But I want you guys to understand that conversation that we just had about no. All right. All right, we got it in there. Hey, let's put in, here's what we do. Hit Zoom 6. Zoom 6 for me, Zoom 6. All right, so here's what we're going to do. So go to your window, please. Oh, turn back on. Go to your window. All right, you guys tell me, what's the lowest x value I have on my scale? -5. I love it. Great. What's the highest x value I have on my scale? 5. Very good. And what are we going by? What's our increments? We're going by ones. Very good. What's our lowest y value that we have? Like -1, 2, like -3, I don't know. -3, -4, -5, somewhere around there. What's our highest y value that we have?
3.
The y value, I see 5, right? And what's our increment? 1. Now let's hit graph. Oh, that looks a whole lot better. What? What do you think about that?
Looks slower.
So is our sketch an accurate representation of the rational function that they have there? Okay, good. How can we verify that this is a 0?
Think of what's called the
Plug it
table.
back in.
Yeah, the table. Very good. The table. Okay. So if we go to the table, and where's my table here? Second graph. There you go. If I plug in a 0, you should see that you get a 0 out. So 0 in, 0 out, you go to the table.
Yeah, but zeros have a lot less numbers.
Mine's set up in an independent ask function. All right, we're going to graph this function. Same 5 steps as before, and we should be able to go a little bit quicker this time with it, all right? All right. Step number 1, what are we supposed to do? Well, there's something before that. Simplify, right? So, could I have x over, how can I factor the denominator here? Yeah, probably a 2 and a 1, right? And then I have to have negative, so maybe negative and positive. Does that look right to you? Who agrees with that statement right there? Did I do it right? Check my work.
Yeah.
Yes, you're right.
Yes, I'm right. Okay, good. Awesome. So there's the simplified version. What's the domain then?
All real numbers.
All real numbers x such that x doesn't equal 2 or -1.
Yep, 2 or -1. Very good. I love it. Nice job. What's step number 2? Very good. X-intercepts. So how do we get the x-intercepts?
Set P of x.
Good. So the numerator represents P of x. The denominator represents Q of x. This one's really easy, isn't it? So x equals 0. Thank you. Love those ones. Okay, third one. Find the y-intercept. How do I get that? Yeah, so I'll have 0 over 0 squared minus 0 minus 2. That's 0 over who cares because the answer still equals 0, right? Awesome. No, that's just my own little crazy thing. You should just know 0 over anything other than 0 is going to be a 0. Okay, 4, here we go. Vertical asymptotes, where would those be? X equals 2 and x equals 1. Remember, negative 1. Those are tied to your domain, right? Okay. Will there be a horizontal asymptote? Yes or no? You guys don't sound very sure. So yes or no? Yes, there will. Okay. Where will it be? Okay, hands up for y equals 0. Hands up for y equals 1. Hands up for I'm not sure. The horizontal asymptote. So because this is a proper rational function, because the degree of the numerator is a 1, the degree of the denominator is a 2, that means the degree of the denominator is less than the degree, the numerator is less than the degree of the denominator, so it's called proper. And we have a theorem we learned on last week that said, if it's proper, then you're guaranteed the horizontal asymptote is the line y equals 0. Okay? So will there be an oblique asymptote then? Nope, because you only get one or the other. All right, good. You guys are ready to go. Set yourself up a nice little xy coordinate plane. And that one went a little bit faster. Is it making more sense to you? The procedure, right, what we're doing? All right, we're definitely going to use our calculator for this one. All right, what is important? What should we put on this graph? Intercepts, yeah. Give me an x-intercept. 0, yeah, okay. Fair enough. Are there any others?
0.
Oh, all right. That's easy enough. Okay, good. What else is important to put on here? The asymptotes. Yeah, where would those be? Wait. Not. Oh, yeah. The vertical. Let's see vertical asymptotes. So here's negative 1. All right. There's a vertical asymptote, and that's the line x equals negative 1. What's the other one? Oops. 2, right? X equals 2. Very good. So there's this one here, x equals 2. Okay. Any other asymptotes total? Y equals 0. Very good. What's another name for this line right here? Nope. Try again. What's another name? Not the y-axis. The x-axis. There you go. So y equals 0. Very good. Okay. All right. So now, check this out, you guys. If I'm going to take a guess here based on the asymptotes, right? I have some options, right? It's either going to be doing something like this or something like this, right? It can be doing one of those two things. Now things start to get a little tricky on the inside here. Now I'm either coming down here, hitting my intercept, and then turning around, right? Or I could be coming down here, hitting my intercept, and then going down. Or I could be coming up, hitting my intercept, and then turning back around this way, right? Or I could be coming up, hitting the intercept, and then going up like that. I got a lot going on in the middle there, don't I? Hold on a second. Hold on. Okay, and it is possible to go through an asymptote around the point 0, remember, okay? Oh, yeah, so then over here, check it out. I'm either doing this, or I'm doing this 2. Okay, so punch into our calculator here. X over x squared minus x minus 2. You got it in your calculator? Good, great. Here's what we're going to do. We are going to go to second table setup, which is window, second window. Second window. Right? Doesn't matter where we do our table start from. Doesn't matter what our delta table is. The only thing that matters in this case is that you set your independent variable to ask. All right? Set it to ask. And then go back to the table, which is second graph. Okay? And we're going to punch in all of our test values at once. Okay? All at once. We're going to punch in negative 2, push enter. We're going to punch in negative 0.5, push enter. We're going to punch in a 1, push enter. And we're going to punch in a 5, push enter. And then we're going to evaluate. So check this out. When x is negative 2, what's the output value, positive or negative? Negative. So that means it's below the graph, right? So that means it can't be this stuff. That means it has to be this stuff here. You guys see that? Okay, good. Let's test out what happens when it's a half or negative 1/2. What do we get, positive or negative? We get a positive answer. So that means that it has to be doing this. It has to be coming down and hitting that point right there. When we test 1, what do we get? We get a negative number. So that means we are below the graph. So that means that we are coming through and going below the graph like that. And then finally, when we test 5, what do we get? We get a positive number, so therefore it must be the case that this is what's going on here, okay? So now I can go back and I can erase all these things here, erase all these other lines, right? And what I'm left with is a graph of the function, and to top it all off, ladies and gentlemen, you get to relish in the fact when you push graph that you... All right, last and final part of this lesson is talking about the oblique asymptotes, okay? What is the degree of p of x here? What's my degree of p of x? 2, very good. What's my degree of q of x? It's 1, okay. Now, so check it out. The degree on top is greater than the degree on the bottom by how many?
1.
By 1. If it is a difference of 1, then you have an oblique asymptote. If it's any other difference, like if it's greater than by 2, 3, 4, 5, you do not have an oblique asymptote. You have something else entirely. So we're only focusing on whether or not the difference between the top and the bottom is a factor of 1. So in this case, it is. This is an example.
Is it only if it's 1?
Only if it's 1, yeah. If it's a difference of 2 or more, it's no oblique asymptote at all.
What about if it's 1 smaller?
Well, then we have it's either proper or it's y equals 0, right? Yeah, we can deal with that.
What is it if it's bigger?
It's called, like, if it's a difference of 2, it's a quadratic asymptote. If it's a difference of 3, it's a cubic asymptote. We don't do any of those in this class.
Oh, is it like the one that's like that?
Yeah, you got it.
And then that's like the asymptote that like stays.
Okay. All right, so I need to figure out what the oblique asymptote is in this case. And the way that we do it is by using long division. Okay? So I take x squared minus x, and I divide x plus 1. Oh, so now we actually have a use for this long division thing. Oh, it makes so much more sense now. And so what we're looking for here is we're looking for a line, y equals mx plus b. We are looking for a linear line because we're talking about an oblique asymptote. So once we get to mx plus b, we can stop. Okay, how many times x go into x squared? It goes into x times. Very good. So x times x is x squared. What's x times 1? X. Very good. And we're going to subtract. X squared minus x squared is 0. X minus positive x is how much? 0. No? Negative 2x. Good. How many times will x go into negative 2? X. Negative 2 times. And you know what? You can stop right there. Because the oblique asymptote is the line y equals x minus 2. Okay? So now, just because we're running out of time, because I did this division, x goes into a negative 2x a negative 2 times. You don't need it. Remember, all you need is a line mx plus b. So once you have a slope and a y-intercept, you're good to go. You don't even have to worry about any of the rest of it. Okay? So now, for the sake of time, okay, because I don't have, is this the one I did? X squared minus x over x plus 1? Yeah. So check this out. Kind of hard to see. Okay? So your asymptote would look like that. That's the line y equals x minus 2. So check it out. It still behaves like an asymptote, except it's just slanted a little bit, right? You could still go through, find the domain, find the x-intercepts, find the y-intercepts, and you could even find the vertical asymptotes, but there will be no horizontal, and there will be a oblique. And here's what the graph would look like, and you would punch it into your calculator and help you sketch it. You could figure out what those points are. Those are the x-intercepts, and you can figure out what the y-intercept is by doing the previous 5 steps, right? Okay, feeling so good about that so far?